Hello. So today is the day before. Yeah. Okay. So today is the test one prep. Not prep. It is the test one review that I'm having. If this helps you, by all means, give it a like or don't. I don't give a fuck. But yeah, so this is it. Alright, I want to start off really quickly by kind of going over a couple things that are pretty important. So, I'm going to call this the things I noticed that fucked me up, which might also fuck you up. Okay, so I'm just going to pull over to the last couple questions I was doing. Now, make sure that you always write your C, your plus C. And be very careful in like your sequential ordering of your steps. So make sure either if it helps you number your steps or just make sure that when you're taking your integrals you always include the plus C. It's a meme on social media. It will get you fucked up because there will be an answer available if you don't have plus C there, and you don't want to fall for that because you'll feel like a retard after. So avoid feeling like a retard at all costs. Secondly, if it looks like shit, it probably is shit. What does that mean? Usually, especially with like those IVPs, the initial value problems, why doesn't this want to go down? There we go. Usually, like let's just say you get like an integrating factor, and this doesn't always happen, but I'm just using it as a quick example. You get something like this, right? So you had your y prime plus y equals 1. You know, you integrated that. We're all cool. Now you get to try to solve your question. And let's just say, in this case, q at x equals something like e to the negative x. Okay? Usually, and I just want to get this across as a point, when you're taking this integral, right, you're going to have your integrating factor times q at x. This cancels out. This is real nice. Usually, with like respect to how complicated this test will most likely be, you'll have something that probably looks a lot worse than this, but you get a nice cancellation, or even something that will like lead you to like a good integration by parts. Okay, so you'll get like something that you can lead into a good integration by parts where it'll work out maybe in like 1 or max 2 integration by parts. Okay. Thirdly, careful with your C. So especially on like the population problems, you'll have like ln p over p minus 3, for example, equals C. Let's just say 4x plus C, right? And when you bring this up, you guys know, but you're gonna get e to the 4x, and then instead of also bringing up the e to the c, so like this is what you can do. It is e plus c, right? This equals e to the 4x times e to c, and in this case you're basically setting c equal to ln c. Okay, and then that way it comes down and it's multiplication now. All right, so that's what's basically happening there, but just kind of get used to from going to this to save your time. And then the fourth thing, and probably the most important thing that you guys already know, but just if you don't, problem recognition. So make sure that at least in your practice, because we have a good, what is it? Let's say you get eight hours of sleep tonight. You watch this hour. I don't know how long this video will be, but like you watch it, you wake up at like 8 or 9. 6 if you're really a gangster, and then you get to work or school, you'll have a good at least like 5 hours to study tomorrow if you set yourself up for this correctly. Make sure that when you do these questions that you're recognizing, like the linear models aren't that bad to recognize. You know what you're getting yourself into. Now, when it comes to like question 6, and I found oh fuck, I can't go there. Okay, hold on. Let me do this a better way. this, guys? Where do I send this to myself that's the easiest to copy from? I always have this problem and no one's helped me on it. What like apps do I have? Oh, I have OneNote. I could probably put in OneNote, right? Oh, that would be amazing. I'll just work in OneNote then. Add a page here. Oh, this is Shannon Affairs. Okay. I think I could just copy them here and then just go at it from here. Okay, hold on. Give me 1 second, guys. Let me get these all copied over, because I don't expose myself. I got people to talk to. You know what I'm saying? So that's why opening Teams is a very dangerous endeavor. Okay, got my questions copied over. Let's open up OneNote. Because there's this one question that I want to mention that specifically is related to like recognizing. And it's not there. I have it in Mathgrams. Hold on. I will sign in. All right, give me a second, guys. Man, this is the wrong email. Man, fuck this. Do. What do I like? Maybe Outlook. I'll just send it to my Outlook. Okay. All right. Share. Okay, this is what I'm gonna do. Hold on. Yeah, okay, I know what I'm gonna do. I'm just gonna download this, and then I'm going to send it to myself, and then copy from there. All right. Give me a second, boys. And I'll probably put this in like the thing. I'll put it as like a part to skip. Or no, I probably don't give a fuck. All right. If I have to sign into this, I swear to God. All right. Okay, cool. Cool beans. Share file. And then save to files. Okay, cool. Okay, cool. Go here. Go here. All right, sick. And then if I import, and then press recents, there we go. Okay, amazing. So the question that I'm talking about specifically is that like this is a good problem for problem recognition. Okay. Now, most people, from what I've seen, they look at this question, they see a bunch of graphs, they all kind of look similar. What the fuck do I do? So, they're presenting you with this differential equation, amazing, and they're asking you on the xy plane, where would it have a unique solution, or passes through the point, blah blah blah. I don't care. I really could not give a fuck about this. I just know that for me to have a unique solution, okay, this has got to be equal to 0, and it can't be fucked up. What does that mean? No ln zeros. Oh. No ln zeros. Okay. No 1 over zeros. Like I shouldn't have anything like that. So quickly, I'm not going to start here, but I just wanted to show you guys what it may look like. Okay. So we're going to start with, and that's really all I have to say in terms of getting ready for it. I'm not going to give the infamous Najat prep for this, which is come into this test like you're going to fail it. Just do your best and everything will be cool. So let's start with this problem. Oh, let's get rid of this. Okay. All right. So I'm just going to take you guys through my thought process in doing this and what made sense to me. And yeah, we'll go from there. So y at x be a unique solution. You got y at 0 equals a. You got y prime equals sine at y, and then that. all possible values of a with the property that correspond to the solution y at x and satisfies this. Okay, so so my solutions would lie when it equals 0, when that differential equation equals 0, right? So what do we want to use? What colors do we want to use today? Let's use a nice blue, feeling blue. All right, so y prime, or let's just say for the most part, we're looking for values that are equal to 0. So I like using c, okay? So for c equals positive, or I'll do it separately. For c equals 2, -2, and then pi, and then 2 pi, and then negative pi, and then -2 pi, etc. Okay? And we're looking for y at 0 equals a. Cool. So I got a bunch of points, and I got to test which ones are feasible. Okay? So I took a lot of points, but this is how I solved the problem. So I put them on my phase portrait. Cool. I also have 0 in here, which is a really nice one. So I put 0. That's like kind of my baseline. Go to 2. Pi is 3.14, so I'll go to pi. 2 pi. Go up a little bit. Positive infinity. -2. Then I got negative pi, -2 pi, and then negative infinity. So like, I just gotta approach this with like a, and let me copy and paste this so it's easy. Oh, why'd that happen? What if I just want this? Cool. Okay, great. So if I plug in 0 here, we don't really look at that. So let's just continue on. If I put in 1, okay, negative, and where's my calculator? Sine of 1 will be a positive number. So I know that I'm going up. Okay, if I put in 2.5, right? So, and honestly, this is how I did it. So 2.5 times 2.5 squared minus 4. You'll also get a positive number, okay? And then you'll get for pi. I don't know if this is the fastest way to do it, but this is how I did it. So then I go to 3.5, and really, yeah. So this is also increasing, because I'm just looking for if it's positive or not, right? And then if I go for greater than that, so I go for something like, what's it called? Like, I don't know, 7, because it'd be like 3.14 times 2, so like 6.28. Let's just go 6.5, just I don't have to leave the 0.5. 6.5. Okay, so this is also increasing. And then, yeah, hold on. Did I fuck up somewhere? Am I in rads? Something doesn't seem right. Oh, I was not in rads. Okay, I was not in rads. My bad. So let's try that one more time. If I go to sine of 1 of 1 squared minus 4, close that. Okay, yeah. I was not in rads. Make sure your calculator's in rads, guys. So, decreasing. And then if I go to 2.5, okay, I'm positive. And then if I go to 3.5, and I'm just going to keep increment these, because you want to do the least amount of erasing to save time. This is coming down. Then if I go to 6.5, oh, 6.5, okay, I'm going up again. Let's go down to -1. And if you're smart enough, you go back, you press the back button a couple of times, you'll be just all right. -1, okay, this is increasing. Then if I go to -2.5, remember the square, you can just keep it the way it is. You don't have to delete the one inside the sign. -2.5, okay, that I'm decreasing. Okay. Then if I go to, then if I go to negative 3.5, okay, then I am increasing once again. And if I go to negative 6.5, then I am decreasing. Okay? Cool. So, what do we got here? I'm just going to name it repeller for R, attractor A. Okay? So I have a repeller. Here at 2, I have a repeller. At 0, I have an attractor. Here, I have... Oh, sorry, I should go by each one. Here, I have an attractor. Okay? At 2, I have a repeller. At pi, I have an attractor. Here, I have a repeller. Okay? So, we are looking for y at 0, which must be included. So, 0 must be included. That's why I said there's a faster way to do what I was doing. I just want to prove a point. 0 must be included in our range. So what does that get rid of? That gets rid of anything below here. Cool? So we only really need to test these points, but I did it for dramatic purposes. Now, if 0 has to be included, and we're saying that the limit as... so like, yeah, for example, C is gone, right? Pi at 2, this is also gone, and this is also gone, because none of these include pi, include 0. And I need that. I need that for this. Oh, hold on. It's saying A is between those values. And these are critical points. Oh, yeah, no, I'm still good. I'm still good. Because it is a function of x. Yeah, so these are all y values. They're all y values, right? So I need to have that because this is my solution. This is f at xy, and it's just saying that y at x equals a, or for better terms, f at x equals a. So my y values, so these are my y values, right? So I need it to be in the range. So what I said was correct. Okay, so then at this point we have these two ones. Actually, we don't even have it. This doesn't even include 0. This is greater than 0. It doesn't equal it. If it was equal, then we could consider it. But it doesn't. So it's just D. Okay, cool. So that's the first question done. How long? I don't know how long I've been recorded for, but let's go to the second. Oh, it's not there, man. Oh no. I could just copy it from here. I really gotta find a better way to do this. Actually, I'll just do it here. That's crazy. Okay. Alright, cool. So, which of the following differential equations are linear? Linear. Alright. So, if we look at the first one, so linear, like what are we defining as linear? So we want pure functions of x as coefficients. So we don't want any of that non-homogeneous shit, okay? Which means it should also be just homogeneous. Sorry, homogeneous would be just one thing. Actually, wait, no, sorry. The new definition that I found for homogeneous was that you could isolate it in a way that you can have 0 on one side and everything else on the other side, okay? This is what, by definition, what homogeneous was. It's not just the fact that it's made up of only y's or only x's. That was incorrect from the questions I had done. Okay, so another thing is y should like just purely y, not y prime, okay, just purely y, should only be to the first power. Okay? And then further to that, okay, we should also be able to, what's it called? We should also be able to put it in the form of like, for it to be linear, where in normal form, that's what they call it, which is y prime equals f at x times g at y. So the respective y function and the respective x function. So with that criteria, let's see what we got here, okay? So we got x, we got this is fine, this is cool, okay? Y, the first one's fine, okay? Now we go to the second one. This is cool, this is a pure function, this is cool, this is also fine. Now if I go to the third one, this also looks fine. I don't see anything wrong with it. Yeah, I don't see anything wrong with it. Why do I feel like that's wrong though? Hold on, I'm gonna check myself. I feel like that I'm like, by my criteria, I know I'm right, but I feel like I'm wrong. Okay, hold on. So, oh, it was only this. Oh, hold on a second. Oh yeah, I fucked on it. Okay, yeah. So I got this question wrong last time, and oh my god. Okay, I should probably cut this out. I'm not gonna take that time to edit this out. So this one's incorrect. Why is this incorrect? Because of this. I didn't check for the normal form. Because I can't get y by itself. Let me just double check normal form. Differential equation example. Just so I'm clear here. Why don't they show us? Okay. Yeah, so I can't get this in normal form because, like, even if I wanted... Yeah, look, guys. So, for this one, this is a learning experience. For this one... Oh, shit. It's okay. Oh, man. This video recording is not the best. Ah, fuck it. It's okay. Let's just keep going. So... For this one, I can't, even if I factored out dy by dx, I'll still have d2y by dx squared. And I can't isolate for dy by dx in any way, shape, or form here. And so that's why this one's not linear, because I can't get into normal form. That's it. So the answer is just the first one and the second one. D. Okay. This one's a good question. I like this one. So this one was the ones I got first time, which I was really happy about. If I put y at negative 0.5, I really gotta charge this fucking thing. Hold up. Please, I really hope it works. If I put the thing in the charger, where is this? There we go. Please tell me it still works like this. Oh, it doesn't. God damn. Okay. I don't know what we'll do, but we'll figure it out. So, yeah, so y at 0.5 and you have t equals negative 0.5. You see how we got a nice line here? And I want to move this over. See how that, like, all of those are zeros? And then also alongside here. That's what I first noticed, okay? So I'm looking in these functions for when I put in y at negative 0.5, I should get 0 for y prime. And when I put in t at negative 0.5, I should also get that. So let's go one by one. First one for y, if I put in negative 0.5, I don't get 0. Gone. Second one, for y, Also don't get it. C is nice. Okay. Now I'm going to skip past C because I know C is correct, but let's go to D. So D, this is good. But if I put in T at negative 0.5, right, I don't get 0. For the last one as well. If I put in Y at that, I don't get 0. So it's just C. Okay, cool. This one's also a nice question. Yeah. So Wronskian. Whenever you see this, equate it to determinant. Determinant of what? Y of... Don't use the N terminology. All of you fucking mathematicians love to make shit hard and complex. Fuck that. Use this. Just, you got the number, y at whatever the number is, over y at the same number prime. That's it. Okay? They're telling you the Wronskian of y1 and y2 equals 4x. So, this is the Wronskian. They're telling me that y2 prime times y1 minus y1 prime times y2 equals 4x. That's what they're telling me. They're saying y1 equals 3. Would you look at that? y1 prime, the derivative of a constant number, 0. Get that shit out of here. y2 prime times 3 equals 4x. y2 prime. And we know amazingly that y2 at 0 equals 6. Okay? Equals 4x over 3. You best believe we're going to put that in this form. Equals, boom, get rid of that. 4x times dx over 3. 4 over 3x squared over 2. Plus c. And then you got this as y. Cool. Okay, if I put in 0, I just get c equals 6. Then, yeah, and that's about it. So then I get y equals 2 over 3x squared plus 6. If you look at that, guys, that looks like c. Cool. Now, and I'm hurrying up a little bit because I don't want my Apple Pencil to like run out. Honestly, I might just take a break and let it charge just so I keep the recording running. But we'll see when it shuts off. All right. By the way, we're only going up to 9 for this because I don't personally think that 10 is coming on the test. He did stuff in that question. Like this is a homogeneous third order differential equation. We did not do this yet. So I don't get why Antoine wanted to cover it. I'm not going to cover it. Do with that as you may. Continuing with question 5. So this one. Actually, I'm liking the turquoise. So you already see this is bad. Just get rid of the x and use y prime to make your life easier. Plus y squared over x, and then y at 1 equals 1. Okay. You love your I at x equals e to the integral of 1 over x dx, e to the ln x. This is over e equals x. Cool. X times y, boom, 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 equals 0 times 0. Integrate that. You're just going to get c. X times y equals that. Y equals c over x. And we have this lovely condition. So, plug in 1, so you get 1 equals c. Amazing. Therefore, this equals y. I should not use an equal. Y equals 1 over x. Whoa, guys. We have an x in the denominator. Watch out. This can't be here. This can't be here. This can't be here. And now you're going to be like, how the fuck did he cross out those so fast? If I put in 0 on the denominator, that shit does not exist. So, yeah. Also, from negative infinity to infinity, there's a really nice number in between there. It's called 0. Also gone. This is our answer. Cool. So, back to this question. Where does a unique solution exist? Okay. So, they're basically telling us that, and at the bottom here, they say explicitly, dashed lines not included in shaded region. Okay, cool. I'm going to go through everything but the answer first. I'll start from the top. A, 1 is included. It is not dashed. If I put this 1 minus 1 minus 1 rooted equals, this is going to cancel. Root -1, that doesn't work. No bueno, gone. We'll skip this. You know why. Okay, if I put in anything like that, I'll have 1 minus a number greater than 1, right? X greater than 1. Also minus a number greater than 1. I don't care what that number is. That's going to be negative. No. Even like they're putting this as a joke. It's kind of like they're trying to laugh. Trying to say that like 1 is also not included. That makes it even worse. They're saying here 1 is included, but it includes everything outside of there. Also no. That just looks retarded. You know why. Why does B work? Why was I trying to link to B so much? All the values are less than 1. And 1 is not included. Like just with knowing that 1's not included, okay, you could already cross out D and E is telling you that nothing is there. That's not true. Because I could have root 1 minus 0.2 squared minus 0.2 squared, let's just say. Okay? And this will be a positive number. And that works. So, yeah, I just need those inside. And I can't have 1 there, so that's why the dash line makes sense there. Okay. This is a good question. So let's do a little bit of highlighting. Now, cup of coffee. Not a coffee drinker myself too much. Heated to a temperature T prime. So they're trying to not tell you that it's T at something with T prime. And it's saying that it's held to a constant temperature. Always look out for constant temperature. And after 1 minute, the temperature of the coffee is measured to be 21 degrees. 2 minutes, 16 degrees. What is the value of T prime? Okay, so they're saying it's heated. In the first sense, they're saying that it's heated. T at 0 equals what? We don't know that. But let's just continue reading. Tm equals 10 degrees. And what's it called? And yeah. And then they're saying T at 1 equals 21. And T at 2 equals 16. And our equation is dt, the temperature, over dt, the time, equals k times t minus tm. So this is our classic integral. I'm going to bring this down, bring that up. I'm going to have kt plus c. You guys saw y. Ln t minus tm. Take your time. Now I bring this up to a power of e. T minus tm equals c times e to the kt. Cool? Now, I need c. If I plug in 1, I'll have 21 minus 10. Okay? So I'll have 11 equals c e to the k. If I plug in 2, I'll get 16 minus 10. 6 equals c e to the 2k. c equals 6 over e to the 2k. C equals 11 over e to the k. You might see where we're going here. Okay? So, 11 over e to the k equals 6 over e to the 2k. 11 times e to the k equals 6. And I'm just going to speed up a little bit. Ln k equals ln 6 over 11. Cool? Amazing. Now, I plug that back into like any one of these two will work. But I plug it back into here, let's just say, right? I'll have t equals 11 over e to the k times e to the kt plus 10. They want t at 0 equals 11. The kt right here will be 0. so I don't have to worry about that, over e to the ln of this will just be 6 over 11 plus 10. 11 divided by 6 over 11, which is 11 times 11 over 6 plus 10 equals 121 over 6 plus 60 over 6 equals 181 over 6. Right there. Okay. This is a good question. So, this question, I fucked up the first time I did it. Reason why I fucked up was because I thought that I could solve. It's not worth telling you guys. I'll just show you. So, I have y prime, I have my y, and I have q at x. I don't see as g at t, I see as q at x. I at x, my integrating factor, equals e to the x. Okay? E to the x times y equals e to the x times g at t. Alright. Now, I'm going to solve first for t is less than equal to 1. Okay? Now, if I do that, I just get the integral of 0 equals 0 plus c. Equals c. This becomes e to the x times y, and y equals c over e to the x. Okay? This is for t is less than or equal to 1. And with that, I can use my initial condition of y at 0 equals 2. And 2 equals c. Therefore, y equals 2 over e to the x. Now, we have this. Now I'm going to solve for t. We'll do it in a different color. T is greater than 1. Cool? E to the x times y equals the integral of e to the x times 1 over e to the x equals x plus c, y 1 over e to the x times that. Okay? You cannot just plug that in. You're using a different condition. That's what I fucked up. That's what I fucked up on. Because this c is for when it's less than, when it's less than or equal to 1. Okay? You can't use it in this scenario where we're solving for when it's greater or equal to 1. This doesn't make logical sense. And so what do? Well, you solve for what you originally have right here for when it equals 1. And why can you do that? Because 1 is the one commonality that these two boundaries share. It's like right in the middle. And I see what you might be saying for like, oh, this is less than or equal to 1. And this is for when it's greater or equal to 1. You're trying to compare when it's equal to when it's greater. But you'll see why it works in a second. So if I put y at 1 here equals 2 over e to the 1, right? And now I want to solve for c. So like what value could I possibly put in here, okay, to get a value out? They want me to solve for y at 3. I don't know anything else of when it's greater or equal to 1. I know nothing else. But I've already solved it here. I've already solved for when y at 1 is equal to it, right? When y at 1 exists. I could solve for y at 3. And you know what? Just to spite you guys, I will. Just to spite you guys, I will solve at y at 3. So now, okay, I'm going to do y at 3 equals, oops, oh my god, okay. So then I'll get 1 over e to the 3 times 3 plus c, okay? This equals 2 over e to the 3 equals 1 over e to the 3, 3 plus c, okay? Cancel this. I'll get 2 equals 3 plus c, and c equals 1. Oh, sorry, c equals negative 1, right? Put that back into my equation. I'll get y at 3 equals 1 over e to the 3, 3 minus 1 equals 2 over e to the 3. You guys ready for something crazy? You guys ready for something absolutely insane? Guess what, guys? Can't do this shit. Can't do y at 3. Why can't you do y at 3? Because this one is only bound for when it's less than or equal to 1. You're forced to do 1. You're forced to. غصباً عن راسك. المدعبل. Basically just cussed you on Arabic. Don't worry about it. So, we continue with where I left off. This is 1. This is 1. Cancel. Cancel. And I put in y at 1. This is also 1. And this is 1. Cool. Now continuing before you guys try to fuck around. You fuck around, you find out. That's the scale. That's the chart. So, y at 1. Over here we have y. We have y at 1 right here. Let me get rid of this y at 3 before you guys start getting confused. Because I know I could see how messy this got really fast. Okay. So, we have that. And so we plug in the at 1. We get 2 over e to the 1 equals 1 over e to the 1. And then we have 1 plus c. Cancel, cancel. We get 2 minus 1 equals c. C equals 1. Now for y at 3 equals 1 over e to the 3. 3 plus 1. 4 over e to the 3. Boom. Boom. Cool. All right. This one's not so bad. You just gotta think about it a little bit. So, let me check Instagram. Your responses on Instagram. Oh, these guys are doing some fun stuff. Okay, I'll help you guys out in a second. All right. Is it separable? Okay. Oh. We gotta. And I think I wrote it down near the end of my solutions, where you have to be careful with like the autonomous and homogeneous bullshit. Okay, so separable by definition, like I said before, dy by dx equals f at x times g at y. So you can get your equation in a way where you just have a function of y and a function of x. Okay, so even if I expand this in, right, and I bring the y to the other side, I still have x. So no, it is not separable. Solutions are decreasing in the first quadrant, or y. So like, why hurt your brain of thinking about it like this? You see it in here. You see right in here. It's x times y is minus 13. So just multiply it up. Is greater than 13. So they're trying to propose that solutions are decreasing in the first quadrant. So in the first quadrant, okay, I got positive x and I got positive y. Okay? Now, for x times y is greater than 13. Now they're telling me solutions are decreasing in the first quadrant. So like, let's just say I have 7 is greater than 13 over 2. So this stands true because if you multiply those out, it's 14, right? And 13 over 2 is like 6.5, right? So this is all true. Now if I plug that in, I will get e to the 4 times 2 squared to the 16. Okay, so I get some huge wacky ass number. Now if I go down just 1, I'll get 6 is greater than 13 over 3. So 13 over 3 is 4.3. We're still good. So now I have 6 times 3. So I have 5 times e to the 4. What's it called? And then 3 squared, 9 times 4, 36. Okay, so now I get a huge number. So I went down 1y, okay, and I went up 1x. Like, this is absolutely wrong in every way, shape, or form. Now, is it an autonomous first order non-homogeneous linear ordinary differential equation? Okay. Now, autonomous is more so, and I don't want to say anything wrong here, but so when I read this question, and I think I might have got it wrong the first time around, but when I read this question, I read first order, which is where my mind, and then non-homogeneous. Okay. Is it a first order non-homogeneous? So it's first order, that's perfectly fine, with respect to y, of course, and now non-homogeneous. It is non-homogeneous. So that was absolutely useless. So we really got to focus on this autonomous part. Okay. Now, if we're talking about what's autonomous and what's not autonomous, all right, we have to really kind of be careful of how we're defining it. Now, when I look at that, right, autonomous, if you want to search it up, I know that for a fact, autonomous has to be something you can get in normal form. Autonomous differential equation. All these fuckers use their... Bro, I hate it when people use these crazy ass, like they make math so complicated for no reason. Why is it like... Man... Okay, a mathematics autonomous system, a system of ordinary differential equations which does not explicitly depend on the independent variable. Okay. A system of ordinary differential equations which does not explicitly depend on the independent variable. So they're basically trying to tell me does not explicitly depend. Oh, I remember this. What's it called? Hold on, I had it before. I had like a simple definition. I'm pretty sure for the most part, autonomous or autonomy is just you only got Y. You only got one thing. Oh yeah, that would make sense. So does not explicitly depend on the independent variable. Basically translates to you only got one thing in there and one thing only. So you got like just Y's or just X's. So this is not autonomous, which makes it none of them. I don't even know if that's right, but let me check. Okay, it's none of them. And the 10th question, like I said, we're not doing that. Now with that, oh my god, people are actually doing this. People are actually doing. Okay, yeah, but yeah, that's pretty much your the review for that. I'm gonna just kind of stick around in the group chat and see what questions I can and cannot solve. So we'll see what happens. Good luck, guys. Oh yeah, and my my formula sheet. This is basically like all I've written down so far. Let me send it to myself. So yeah, that's all I've written down. That's basically it. Because like the formula sheet's fucking useless. But yeah, take it easy.